Hello, my geometry friend. In this video, I am going to discuss coordinate geometry, and we are at topic 3 here. So this is when two things are going to happen in this video. One is we're going to determine what type of quadrilateral we're looking at using coordinate geometry, and two, we're also going to use coordinate geometry to find a missing point. So I included in this notes the flow chart that we used back when we studied quadrilaterals in proofs. But now we're talking about quadrilaterals on the coordinate plane. So we'll talk about how the difference is here. So we learned about these different kinds of quadrilaterals and what makes them similar to each other, but also what makes them different from each other using some certain properties. And in this lesson, we're going to revisit these shapes, but this time we're going to use this thing called coordinate geometry to classify or justify the type of quadrilateral that we're looking at. So quadrilaterals are they are trapezoids, they are parallelograms, they're rhombus, rectangles, squares. Those are all types of quadrilaterals, and each one has its own special set of characteristics that makes it what it is. Okay, and so now when I talk about that in terms of coordinate geometry, that means we're going to use the tools that we have, the distance tool, the slope tool, and midpoint tool. Those three things are the three tools that we have for coordinate geometry. And so if I zoom way in here, I know it's super tiny, but if we zoom in and I look at the trapezoid says it has one pair of opposite sides that are parallel. Well, what we learned previously is that if I want to show lines are parallel on the coordinate plane, the xy axis, I could find the slope of those two lines and show that they have the same slope. So if I want to prove the sides of a trapezoid are parallel, I would find the slope of those two sides and show that they have the same slope. Or if I was looking at like this parallelogram property that says both pairs of opposite sides are congruent. If sides are congruent, that means they have the same length. So if I wanted to prove that both pairs of opposite sides are congruent, I would find the length of all four sides of my parallelogram and show that the two longer sides are equal and the two shorter sides are equal in length. So that's me using distance so that I can find or prove these properties of quadrilaterals. Now, when we justify our claim, we need to use very specific language. And I was afraid that if we don't practice this enough, you wouldn't really have the vocabulary. So what I did here at the bottom is I gave you like a table of different ways that you can support your answer. Okay, so depending on what information you have or you find, this is the property that you can justify. So over here it says if you're given lengths of sides, if you know the length of a side, that means you can either prove one pair of opposite sides have the same length, so they're congruent, or both pairs of opposite sides have the same length, so they are congruent, or all the sides have the same length, so all the sides are congruent. So you see length, and I see the word congruent. So when we're thinking we want to prove segments are congruent, I need to show their lengths are the same. Or same thing with diagonals. If I wanted to show the diagonals are congruent or are not congruent, I would also measure their length. Now, so on my table here, if I was, gonna kind of like separate things out here, so I have this side of the table is talking about lengths, given lengths of sides, given lengths of diagonals, and you see in all of here, wherever I have, and all of these say congruent, 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 congruent. So when you see the word congruent, you should be thinking length in coordinate geometry. Whereas on the other side of the table, this is talking about slope. And so over here, I see that I have some slopes, and my picture's in the way, so I can't quite make my square, but good enough. So over here, I'm talking about slopes. And so we have when you're given slopes of sides and when you're given slopes of diagonals. So think about in coordinate geometry, what does slope show? Well, slope can show if lines are parallel, and slope can show if lines are perpendicular. So that's what I said here, that when opposite sides have the same slope, they're parallel. Or if both pairs of opposite sides have the same slope, then they're both parallel. Or if, this one's tricky, adjacent sides have negative reciprocal slopes. Now, what does it mean to be an adjacent side? I have a picture right up here in the corner. See, adjacent sides are when two sides meet at one of the vertices of the shape. That's what adjacent sides mean. And if the adjacent sides have negative reciprocal slopes, excuse me, that means they are perpendicular. Okay, and certain shapes have diagonals that are perpendicular, like the rhombus and the square. And so if the diagonals have negative reciprocal slopes, then they must be perpendicular. Okay, so that's all of how we can justify what we're doing. Well, let's take a look at the kind of question that we have to see, and then we'll justify from here. So look down here. Here's example 1. Use the given information to determine the most specific name for the quadrilateral ABCD. Be sure to justify your answer. Okay, so here, the information that I'm given is I have M of segment AB, M of segment DC, M of BC. What does M mean? M means slope. So you're given a slope over the side from A to B, and then a slide of D to C, and B to C, and A to D. So one of the things I might want to do here is just draw myself a picture. Now, here's where I don't want to mislead you, because I have a tool that's called a rectangle tool, and I don't want to make you think that I'm drawing a rectangle. I just want to draw a four-sided shape. So really, how about I do this? I'm going to just draw a four-sided shape like this. Okay, and it's nothing special about this shape. It just has four sides. And then when I go in here label, if this quadrilateral is called ABCD, that means one of the vertices is A, and then another one is B, and now this one down here has to be point C, because you have to go around the shape, either clockwise or counterclockwise, and that leaves point D right here. So when you see this information that we're given over here, that you have the sides A, B, and DC. See, those sides are opposite of one another. AB is up here and DC is down there. Those are opposite sides. And you see what we have right here? It says those opposite sides have the same slope. So now what you need to do is link together when two sides of a quadrilateral have the same slope. What does that mean about those sides? And what you should say is that means that the side AB must be parallel to the side DC. They have the same slope. Okay, then likewise, here where we have the side BC and AD are also -4/6. The slope here is -4/6. They have the same slope. So that means that those sides of BC and AD are also parallel to each other. Okay, so that's what I know so far. The two connections I've made so far, that these two slopes are the same, so these two segments are parallel, and these two slopes are the same, so these two segments are parallel. But there's actually one more thing, because so if I'm given slope, I'm thinking up here, what do I know about the slopes? Do I have slopes of sides? Yes. Do I have slopes of diagonals? No. I don't have that information, so I cannot talk about the diagonals. I can only talk about slopes of sides. Okay, so do I have only one pair of sides parallel, or do I have both pairs of sides parallel? Well, I have both. Okay, but there's one other thing that I got to look at, and that's this thing right here, the adjacent sides. Do the adjacent sides have negative reciprocal slopes? Okay, well, let's take a look. So my adjacent sides are sides that are next to each other. So let me use the purple here. DC and BC are next to each other. So what if I take a look at just those two right here, DC and BC, and are the slopes 3/2 and -4/6, are those slopes negative reciprocals? Well, here's a little trick. Okay, and I know I hadn't talked about this a lot before, but if I want to see if something's a negative reciprocal, take the number 3/2, multiply it by the number -4/6. That kind of looks like a minus sign. I want to multiply by the number -4/6. And what's going to happen is if I multiply these two things and the product of that is -1, which it is, that means that those sides, BC and DC, are in fact perpendicular to each other. So I'm going to put a little right angle symbol right here. Okay, and so now with all this information, I want to try to justify what I know about this shape. I want to try to place this shape. So let me go back up here and think, how can I decide what shape I'm looking at? Am I looking at a parallelogram? Am I looking at a trapezoid, a parallelogram, a rhombus, a rectangle, a square? Which one does it have to be? Well, I have more than just one pair of opposite sides parallel, so it's better than a trapezoid. So I'm going to keep flowing down my chart here. Then I go to parallelogram. I do have both pairs of opposite sides are parallel. That's true. So I definitely also have a parallelogram. So it is a trapezoid, it is a parallelogram, but can it be more specific than that? And yes, because what a parallelogram does not have, but a rectangle does, is a rectangle has all right angles. It has opposite sides that are parallel, and it has right angles. So down here, the way I'm going to answer my question is like this. Let me just pause and I'll show you how. So my answer right here, ABCD is a rectangle because here's my justification. Be sure to justify. I need to use the word because, and then I'm gonna basically cut and paste what I wrote up here to justify. I have both pairs of opposite sides have the same slope, so they are parallel, and adjacent sides have negative reciprocal slope, so they are perpendicular. That's what I wrote right here. Both pairs of opposite sides have the same slope, so they are parallel, and adjacent sides have negative reciprocal slopes, so they are perpendicular. So that's why this must be a rectangle. It's not a square because I don't know the additional properties of to make it a square. It doesn't have all sides are congruent, or it does not have, I don't know what other information it has. I can only use the information that I'm given to make the best choice possible. Okay, let's look at one more of these. So here it says example 2. And in example 2, this is where I'm using this information again, determine the most specific name for the quadrilateral ABCD. So now it says AB equals, BC equals, CD equals, DA equals. This is not slopes. These are lengths. I'm given the length from side from A to B, the length of BCs and CD and DA. And I can see that all 4 of these lengths are equal. And I'm also given the length of AC. Well, let me draw a picture here quick and just see what this thing looks like. So if I have ABCD, so let me draw, again, I'm just going to draw a kind of random quadrilateral, and I'll call it ABCD. See, I'm going in reverse order this time, and it doesn't matter. As long as you go clockwise or counterclockwise, you're fine labeling it how you want. So when they say A, B, C, D, or no, A, B, and B, C, and C, D, and D, A, B, and B, C, and C, D, and D, A all have the same length, that means I know that property has to be true. But I also know that the line that goes from A to C, see here now, and I see it on the picture, A to C, that's a diagonal. Sorry, that's kind of a curved diagonal. But then I go from B to D this way is also a diagonal. And these diagonals are also congruent to each other. So when I'm thinking what's the most specific name I can have for this shape, again, let me come up here and zoom in where I see a rhombus has all sides are congruent, but a rhombus does not have diagonals that are also congruent. That's something that the rhombus combines with a rectangle to make a square. A square has all sides are congruent and has diagonals that are congruent. So now, based on the information I have, I'm going to say that this shape is a square, and the reason being that when I'm given lengths, I have all sides have the same length, so all sides are congruent, and diagonals have the same length, so they are congruent. Okay, so that's what I'm going to write in as my answer right down here. Okay, so ABCD is a square because all sides have the same length, so all sides are congruent, and diagonals have the same length, so they are congruent. Now, that's the first part of this lesson, and that's like using information that you're given to classify the quadrilateral, the most specific name for the quadrilateral. I'm going to come back with a second video to talk about finding a missing coordinate.